Hi, my name is Chris, just in case you didn't see the first two videos, and I'm going to talk about the HDMI replacement for the VIC chip that I have been working on, and I have it set up in this shortboard version of the VIC20. Okay, there are essentially three parts. So you have the LS138, a small board with an LS138 on, which is replacing the 138 here. And the idea of this board is to provide a header so I can easily connect on the address lines for this. So the address lines are A13, A14 and A15. The second board I put is this route through. So this is to connect this side of the data bus to this side of the data bus, because on the normal VIC, this side and this side are isolated, so the VIC chip can read the memory. But if you're using the HDMI board, it's not necessary, since all the memory can be put inside here. So I just show what these boards look like. So this is the 138 board, and this is the route through board for the 245, so they're quite simple. Now I shall look at this board. So this is the board for replacing the VIC chip. So to replace the VIC chip, you first need to remove it, and you also have to remove the cage. Otherwise it won't go in. And then where the VIC chip was, you need to insert some, not an IC socket, but some headers. So the headers are these kind of things. So you need to insert a 20-pin header here and a 20-pin header here. Then this board will just slot on. And there are also two standoff mountings, so you can secure the board to the main board so it doesn't wobble around too much when you're inserting cables. And this is the $10 speaker module, which I referred to in earlier videos, which you can buy from AliExpress. So this has a direct connection into the board. And you can see that I have a connection from the one straight here, where the address lines are, to here. Okay, this board is a Tang Nano 9K. And it's a relatively cheap FPGA. It's doesn't have as much resources as the CMOD S7 I showed earlier, but it has enough resources to do the job here. And more importantly, it has this HDMI connector. And this allows for a digital video interface to the modern monitors. So in the design of the FPGA here, I've set it up such that this will drive 768 lines vertically and 1024 pixels horizontally. Now when you divide the number 768 and 1024 by 3, this will correspond to something like 41 characters wide and 32 characters deep. So bigger than, it should be big enough for most of the VIC20 applications. Also in this chip I have provided full memory expansion, so you can put all the memory in here for the VIC20, or you can still leave these chips in, and then you enable a switcher so you only use this part of the memory here, and then this will fill in the holes. The character ROM is integrated into this chip, so this is not needed. And similarly on this board, the character ROM is integrated into the FPGA part as well. And moving on, we have some dip switches. So M0 and M1, they are used to set up the various memory configurations this will support. Then 1 megahertz, 2 megahertz, this provides the system clock. So normally the system clock will be 1 megahertz, but you can change it to 2 megahertz if you wish. And this PAL and NTSC, this will be changed on future revisions of this board, but it will switch in special functions which you wouldn't normally see with the VIC chip. So things like an additional sound generator, you can change the border character, you can change the colors beyond the ones which the VIC chip would have. So more things can be switched in. And I'm looking at doing keyboard things so you can make fine adjustments if a game doesn't display properly. Anyway, work on this card is still ongoing, so it's not really ready for sale yet. But the other 2 cards are ready for sale. The other 2 cards I featured in other videos are for sale, so you need to contact me through the Facebook VIC20 group or Commodore Hardware Repair group, or you can just leave a message on the YouTube and I'll get back to you. Okay, that's all. Thank you. Bye bye.